Hello friends, myself Fayamarade. In previous lecture, we see the velocity diagram and formula for Pelton wheel turbine. In today's lecture, we see the example on Pelton wheel turbine. So, let's start the problem on Pelton wheel turbine. Remember points of Pelton wheel turbine is in previous lecture we see the maximum velocity, how to obtain maximum velocity 1 plus cos pi upon 2. Next lecture, so firstly the velocity of jet at inlet v1 is equal to cv under root twice gh, where cv coefficient of velocity, so 0.98 to 0.99, h is a net head. The velocity of u is given by phi u root gh. The speed ratio and the value of speed ratio is varies from 0.43 to 0.48. The angle of deflection of jet through bucket is taken as 165 degree. So mean bucket diameter is u is equal to pi d upon 60. With the help of that, d is equal to 16 u upon pi n. We can calculate. So firstly write down this. Remember points. So this is a remember very important points for problem on Pelton wheel. So next is the jet ratio. Jet ratio is defined as the pitch circle diameter of Pelton wheel to the diameter of jet. So it is denoted by m d upon d. So let's write down this Pelton jet ratio. M is equal to d upon d. It is defined as pitch circle diameter to the diameter of jet. So next is a number of bucket on runner is given by z is equal to 15 plus t upon 2d, that is a 15 plus 20.5, that is a number of bucket z, which is applicable in next problem. So number of jets, it is obtained dividing the total rate of flow through turbine by the flow of turbine. So again we see the maximum efficiency, how to obtain the maximum, show that the maximum in question, so that the maximum is 1 plus cos phi upon 2. So the efficiency, the question asking problem in the exam is, show that the maximum efficiency of Pelton wheel turbine is 1 plus cos phi upon 2. So in that they show the hydraulic efficiency 2u v1 minus u 1 plus cos pi upon v1 square is equal to 0. So which is a shows in 0. So whenever it shows 0, the 1 plus cos pi v1 differentiate with respect to u is apply, there is apply product rule. So 1 plus cos phi upon v1 is a constant. So derivative of 2u v1 is a twice u square is 2u v1 minus twice u square, which is 0. So which 1 plus cos pi upon v1 is transfer in left side, that becomes 0. So after calculating the 2u v1 velocity is 2v1 minus 4u, that is velocity is 4u. So with the help of solving equation, the u comes out is v1 by 2. So put in equation, with the help of that, the Pelton will be given maximum velocity when wheel is half of the velocity of jet at inlet. So this expression will be obtained substituting this value u is equal to v1 by 2 in equation efficiency. So hydraulic efficiency is equal to v1 minus u 1 plus cos pi upon u upon v1 square. So v1 minus v1 by 2 1 plus cos pi v1 by 2 upon v1 square. So 2 into v1 by 2 1 plus cos pi v1 by 2. So v1 square, so is equal to 1 plus cos pi upon 2. So this is a value of efficiency, maximum efficiency. So write down this derivation, which is very important in exam. झालं असेल तर सांगा मला, नेक्स्ट घ्यायला आपल्याला. So let's see the problem. So first problem is a Pelton wheel mean bucket speed is 100 meter per second with jet of water flowing through at a rate 700 liter per second under a head 30 meter. The bucket deflates to jet at an angle 160 degree. Calculate power given by water to the runner and hydraulic efficiency. Assuming coefficient of velocity is 0.98. So in that, u is equal to u1 is equal to u2, 10 meter per second. So q is equal to 700 liter per second divided by 1000, that is a 0.7 meter cube per second. Head of water is given 30 meter. So when angle is given 160 degrees, so that is a phi is equal to 180 minus 160. So that is a 20 degree. So CV is equal to 0.98. So V1 is equal to CV under root by GH is equal to 0.98. So in that 2 into 9.81 into 30, that is a 23.77. So VR1 is equal to V1 minus U1, which is given. So 23.77 minus 10. So that is a VR1. So VW1 is equal to V1, which is shown in figure. So V1 is equal to 23.77. So VW1 is out. Next is in outlet triangle. VR2 is equal to 13.77. So VW2 is equal to VR2 cos phi minus U. That is 13.77 cos 20 minus 10. So 2.94. So the work done is rho A V1 VW1 plus VW2 into U. So M1 mass of water is 1000. So into 0.7. So with the help of that, the value is 1869.17 divided by 1000 is the 186.97 kilowatt. So after this, the hydraulic efficiency formula is 2 into VW1 plus VW2 into U upon V1 square. So with the help of that, the 2 into 23.77, put the value of VW1, VW2 and U. We get hydraulic efficiency 0.9454. So in this way we calculate the example. So write down the example. So write down next how to calculate the efficiency 94.54. So next is a calculate the efficiency. So in this way, in today's lecture we are completed the remember point, basic point of Pelton wheel and example. So um, let's see the example on next lecture.